Hey everyone, how are ya? I am on page 24 of your polynomial packet. This is our last new topic that we have to do for this unit. Your unit test will be on Friday, right before break. So I am on page 24 of your notes. Factor completely. So we kind of put everything together today. So it says always, always, always take out a GCF. Okay, you might have to group things together. We'll talk about that at the very end of the sheet. Then we're going to factor the difference of two perfect squares, factor into two binomials. And then make sure here you actually look at what you have and ask yourself, can I go further? Because sometimes you can break those up a little bit more. Okay, so let's look at number one. Is there a GCF? Yes, there is. Pull it out. Do you have the difference of two squares? Yes, you do. So factor according to the pattern. Okay. Now, number three. Do you have a GCF? Yes, you do. Pull it out. Do you have the difference of two squares? Yes, you do. Factor accordingly. Okay, there's nothing else to factor. Number five. Do you have a GCF? Yes, you do. Pull it out. Do you have the difference of two squares? No, in fact you have a trinomial. So it's not a perfect square trinomial. So let's factor. I'm going to say 5 and 2, because 2 times 5 is 10, and 5 plus 2 is 7. Remember, if you want to check any of these, you can distribute and FOIL back in. Okay. And you guys might want to, too, if you want, you could write these like this. I don't know if that makes it easier for you, because you pulled this out, and then you really have this. So this is this, and then this is these two. Maybe that makes more sense for some of you. Okay. So now 7, we have a GCF of 5x squared. So I end up with x squared plus 2x plus 1. This is a perfect square trinomial. X plus 1. Those of you who didn't see it, you'll get this at first. 1 times 1 is 1. 1 plus 1 is 2. And then you'll see, oh yeah, I can write it like that. Whoops, and you can't see that. Sorry about that. Didn't realize I was off. So once you factor to this, if you don't realize it's a perfect square trinomial from here, you'll factor like this, see that they're the same, and you can write it with the squared. Okay, let's try the next one. We have something in common. GCF, pull it out, you get z squared minus 1. That is a is the difference of two squares. So you can factor it into z plus 1, z minus 1. And again, maybe the brackets help some of you. Not sure if they do or don't. Okay, then the last one. It is the difference of two squares. So you've got z squared minus 1 and z squared plus 1. Oh, you have the difference of two squares again here. So you've got z minus 1, z plus 1 times z squared plus 1. Okay. Let's look at number 6. Again, guys, I know I'm moving right along, so this is a video. You can stop it. You can pause it. You can replay it. In 6, you have a GCF of 2a. And then I've got, if that helps you, then I've got x squared minus x minus 6. So I'm thinking 3 and 2, x minus 3x plus 2. Okay. Let's try number 12. Okay, now this at the beginning I talked about this group if necessary. So when I come down here and I look at number 12, at first it looks like I can pull out a W. But then I get back here and there's no W. So I look this way and it looks like I can pull out a 3. But I get up here and there's no multiple of 3 to pull out. So what I'm going to do is actually group these together into two binomials. So I'm going to pull out a GCF here, which is actually a W squared. And I'm going to get W minus 3. I'm going to pull out the 9 here, but it's really negative. So then I'm going to get W minus 3 as well. You'll notice that these two are the same. I'm going to factor it out, just like I did the GCF here. So I'm going to write it once out front, and then I divide each term by it. So this would cancel, leaving me with W squared. And divided out of this term leaves me with 9. So now, difference of two squares is here. Okay, so the difference of two squares factors into that. You'll notice you have two of these. I'm going to turn the paper sideways on you guys. So we really have W minus 3 squared times W plus 3. Okay, now let's just work in reverse to check it. So I'm going to draw a little line there, and this is my check. So that's W minus 3 times W minus 3 times W plus 3. So FOIL these ones. That's W squared minus 3W minus 3W plus 9 times W plus 3. So that's W squared minus 6W plus 9 times W plus 3. So that's W to the third plus 3W squared minus 6W squared minus 18W plus 9W plus 27. Combine like terms. You get W to the third minus 3W squared minus 9W plus 27. Okay, so that's my final answer, and it does actually match what I started with. So this right here is your final answer. Then, of course, you can check it. So what's nice about this unit is you can check everything, so when you turn in your test, you know whether you got the questions or you have the questions right around before you turn it in. Okay, so review anything you need to review, replay the video, play it slower, pause it, listen to a problem, try a problem, do whatever it is you have to do. And then I want you to complete for class tomorrow, number 2, 4, 8, and 10. Okay, so that's your homework for tonight. It'll be checked tomorrow in class. Now, tomorrow in class, we're going to do some practice. You'll notice in your notes packet that there's actually 2 pages of Fact Check Completely. We're only going to spend 1 day on it so that we can test before we go on break. Otherwise, it's a week of break, no math, and coming back to a test, which you won't perform well on. So this page is actually page 26, and I'm going to have to do it in a separate video, guys, because my class is about to come in. So I'll pick up here page 26 in a separate video. I'm just going to walk you through the answers so you can do it on your own. So look for that in the next video, because I have to go teach a class.